Hi, everyone. My name is Courtney Gold. I will be your moderator today for today's webinar, which is Log4Shell Vulnerability, All You Need to Know. This is an important webinar, and we're happy to have you here today. I want to introduce our speaker. His name is Shachar. He will be telling you everything you need to know. Just before we get started, a couple housekeeping items. There is a Q&A chat box right below you at the bottom of your screen. Please use that. We will be answering your questions, hopefully during or post after the webinar is over. Secondly, just so you know, we will be sending out this recording within 24 hours along with other assets that will be important for you to know. But other than that and anything else, I will hand it off to Shachar. Go ahead. Thank you.
Thanks, Courtney. Just a quick introduction. I'm Shachar Menashe. I'm the Senior Director of Security Research at JFrog. Basically, I manage all the security research teams. So obviously, this Log4Shell vulnerability has been a huge problem and huge thing on the internet right now. Our security research team has been looking at it since it was reported, last couple of days, and basically trying to understand all the attack vectors, the fixes, the mitigations, false positives. There's a lot of noise and a lot of information about this vulnerability. So basically in this webinar, we wanted to aggregate everything in one place so we can give out a concise explanation to everybody and just help vendors understand what is the real impact, are they actually impacted, what are the available fixes, and what are our recommendations for mitigating this issue. So let me jump to the slides as well, so we'll have a visual cue as well. Great. So first of all, we wanted to explain about the vulnerability, why is it so critical, what's the root cause of the issue, etc. So what is the Log4Shell vulnerability? Well, first of all, it's a critical remote code execution vulnerability. It affects the Log4j logging framework for Java, one of the most popular logging frameworks. It got assigned to the CVE 2021-44228. It has the highest score of CVSS 10, which is always a problematic factor. So what actually happens with this vulnerability? That the vulnerability is triggered when an attacker can control a string that gets logged with this logging framework. So the logging framework has a lot of APIs for logging, like log.info, log.debug, etc., etc. So here we're seeing some example of log.info, and the idea is if an attacker or some malicious factor can get a special token inside any of the strings that get logged, then the attack takes place. This is problematic because usually logged strings are not parsed in any way, and they're considered to be very trustworthy resources, so they don't need to be validated or filtered or anything. It's just strings that are logged out. So in this case, the strings are parsed and can be doing malicious activity just from having malicious text logged out. So that's why it's a very problematic issue. So again, this is critical because exploiting it is extremely trivial and 100% persistent. It's not a statistical exploit or anything. There are public exploits available on the internet. So basically, any attacker can just download an exploit. It hosts a server on his machine, his or hers, and then just brute force send out these malicious tokens to every web application, every website, every API that the attacker sees, and just wait and hope for exploitation. So it's extremely trivial to exploit for even novice attackers. The second problem is that this logging framework is massively popular. It's being used by third-party vendors. It's being used directly by developers. Basically, anyone that is using a Java application might use this logging framework. There are other frameworks like Log4j 1, which is a previous branch of this. which isn't susceptible to this exact issue. There's the logback, which is another popular one, but Log4j2 is one of the top ones. So it's used it's very, very ubiquitous. So the issue is everywhere. And because it also got such a wide media coverage, there's a ton of attacks happening right now. The third issue is, again, it's not enough that you have the package installed. You also need that some remote input would actually get logged, like remote input from an attacker. The problem is that it's extremely likely that untrusted input will reach a logging function, because usually when you log something, you want to include parameters from whatever remote location, or you want to include what happened. So it's very, very likely that untrusted input will make its way to one of these logging functions. Of course, we also have a companion blog post, which will be sent in the collateral material, and we specify an exhaustive list of all the logging functions that you need to look out for. But it makes sense that in some way untrusted input will reach a logging function. What we saw online is that the most common attack vector is actually including this attack string in the user agent when doing HTTP requests, because usually on the server side, the logger will just say what was the user agent that did the request, and then once that gets logged again, the attack happens immediately. So that explains a bit about the vulnerability itself, but not what caused it. So we're trying to keep it a bit technical, but still high level. So actually, this vulnerability is extremely interesting because I would say it's not a bug in the programming. It's actually just a feature that was added quite a while ago, and nobody thought of the security implications of this feature until now. So actually, there's no bug to exploit here, but it's just a feature that, in this case, allows for remote code execution. The type of the bug is the unsafe class deserialization, a very well-known type of Java bug. And this is caused due to a Log4j feature that's called message lookup. So basically, when you log out a message, usually in every logging framework, when you log something out, it doesn't get parsed that much. It just logs it out verbatim. But in Log4j2, there's a feature that's enabled by default in the older versions that just looks for specific tokens in the logging message and replaces them. So, for example, if I would log this token, like $, curly brace, Java, :runtime, if I send this out to be logged, what would actually be logged would be Java version 17067. So it gets replaced automatically. And this is by default. So usually this is harmless. It can actually be harmful because of information leakage. But the bigger issue is that there's actually a specific type of lookup called the JNDI lookup. And what this lookup does is it loads a remote class using JNDI, which is a directory service for specifying classes, which can be either local Java classes or remote ones. So this lookup allows loading a class and then outputting a specific variable from the class. So outputting the value of a specific variable from the class. So the problem with this is first of all that the class can be hosted remotely. So you can have a string that accesses a different machine, like a different computer, to retrieve the class. And it's not just classes that are stored locally on the machine in your class path. And the second problem is that in order to evaluate the value of the variable, the class needs to be deserialized, which means the class is actually executed. So it's running code from that class. So combining these things together, it means that if I specify a string, like I showed in the last slide, and this is the most naive type of attack string, but there are other ones which we'll share as well, which are obfuscated. But for example, this string, it means the Log4j will go to the attacker server, and fetch an arbitrary class, whatever the attacker hosts on that server, and then execute that class, which basically means that arbitrary Java code is running on the vulnerable machine. So this is classic unsafe class deserialization, which leads to remote code execution. We also highlighted in our blog some problematic lookups besides JNDI, which are worth looking at because, for example, your web application firewall might not be looking out for them. So we'll share that in the collateral material as well. I won't dive too much into this, but this is the way that our attack looks like. This is also available in our blog, so you can check that out from there. Basically, the attack string gets sent. In some way, it must be logged out. So this depends on each specific application, but again, it's a very common scenario that it's logged out. This triggers an LDAP query, which is a protocol that basically helps reference the Java object through JNDI. So the attacker returns here whatever he or she wants, but basically returns the same server and references a name of a malicious class. It could be anything. It's just going to be the class that's going to be shared afterwards. The vulnerable server sees this and then goes to whatever server the attacker sent him to. Here it's the same server that initiated the attack. Here it's through HTTP. It can be through HTTPS or whatever other supported protocol. And then the attacker can supply whatever arbitrary class, and that class would be run on the server. And here, there's just an example of something that deletes all the files on the machine, but of course it could be something more clandestine and basically anything. So besides the attack diagram, we wanted to start talking about some of the questions that we got as a DevOps vendor since this vulnerability was disclosed. I would say the first thing that we got asked the most is regarding, of course, whether we're affected. So there's a few things that I wanted to elaborate on that. So first of all, we also sent out a formal response and tweeted right away that JFrog products are not affected. That's because we just don't use this vulnerable package, Log4j-core. So none of our products do. So actually, it was a pretty easy check on our side. But some vendors that actually scan our packages with other dependency scanners, like not JFrog Xray, but other ones, for example, flagged the Log4j API package, and that got flagged as vulnerable to this CVE. So no matter how we try to push out this message, we still get asked. But basically, the Log4j API package by itself is not vulnerable. So we checked that ourselves as the security research team before this detection data was uploaded to JFrog Xray. So we did a static check, a dynamic check. It's also actually mentioned in the official thread of this issue in the Apache Log4j2 forums. So we feel very, very confident in saying if you have some package and you only have Log4j API, the Maven package, and you don't have the Log4j-core package, then you are not affected. It does make sense in some scenarios that you have Log4j API and don't have Log4j core. For example, you may use the Log4j API and your backend might be Logback or any other logging framework, actually. So this is a scenario that happens, but you are not vulnerable if that happens. It was very important for us to emphasize this because this is maybe the questions that we got asked the most. The problem is that some security vendors flag this package as vulnerable as well, and not just Log4j core. And that's what caused the confusion. So a lot of like open source tools and even commercial vulnerability scanners treated this package as vulnerable, and it's not. Another thing that we got asked is whether if I just have Log4j core, let's say, installed on my machine, but I don't call any of the APIs, or I call the logging APIs only with constant data, like nothing that comes from remote input or any variable at all, just literal constant string. In that case, you are also not vulnerable. So that's also very important to say. So in our blog post, we actually talked a lot about recommended fixes. I wanted to touch about that because that's obviously another point that we got asked a lot. So first of all, the best fix is to upgrade Log4j. We're aware that not all vendors can do that, so I'll talk about mitigations as well. But that's the best fix. And for the paranoid, we also have another suggestion, but let's talk for a second about upgrading Log4j. So there are two versions. There's two stable releases that you can upgrade to right now. There's 2.15.0, which we reckon that's what most of the vendors upgraded to by now. And there's a 2.16.0, which came out today or yesterday. Depends on your time zone. So 2.15.0 actually takes care of the issue pretty well. What 2.15.0 does, first of all, it disables message lookups by default. So there's no funky strings that can be logged that will cause any lookup behavior in any case, unless by default, unless you purposely enabled this behavior. So this change by itself takes care of pretty much most of the issue, unless you tinkered with the configuration. And there was another important change that basically, even if you're using JNDI in any way, not through message lookups, although right now it's uncertain, like for a easy exploitation vector for that. But even if you are using it in some way, then it's constrained only to specific protocols, which is LDAP, LDAP-S, and Java, which is a local only protocol. And for the remote protocols, the default remote protocols, it's also constrained to local IP addresses as well. So for example, the string that we saw before, like LDAP with remote hostname, that would not be allowed, even if message lookups were enabled, which is not the default in 2.15.0. So basically with 2.15.0, we feel pretty confident to say if you're upgrading to this version and you don't tinker with the configuration, like it's a default configuration, then you should be safe. There's also another upgrade available, which is 2.16.0, and that takes it a step further because this became such a big deal, and actually, you know, these like both JNDI and message lookups also have performance considerations for the logging framework. So in 2.16.0, JNDI, any support for JNDI was disabled by default. You can still opt in and enable it, but it is using Java properties, but it's disabled by default. And the message lookup mechanism has been completely removed. So now you can't even opt in to that mechanism. It's just been removed. So if you want to be perhaps extra paranoid and maybe gain some performance, then you can also upgrade to 2.16.0, but 2.15 on the default config should also be sufficient to remediate this issue. And it's one of the best fixes. So I would say you have like, this is the best fix and this is what you should do, but why is it not perfect? For example, to upgrade to 2.15.0, we are still afraid of human errors. For example, let's say you have Log4j as a direct dependency and also as a dependency of a dependency. Like let's say you're using some third-party package which uses Log4j, and that third-party package may not be updated yet, and you don't even know if it's vulnerable to this issue, which everybody right now is scrambling to understand, like what are all the packages that are vulnerable, and not just if you're using Log4j directly. So the human error part here is that you might, by mistake, not upgrade all of your dependencies to 2.15.0. If you do upgrade all of them, then you're fine, but it's problematic. So in addition to upgrading 2.15.0, we also recommend doing one of the mitigations. Again, it's explained very thoroughly in our blog post, but there's an environment variable that you can set globally on your machine. And then it's a great factor because then this machine will be completely safe from the message lookups issue. Like it disables the message lookups feature, so it doesn't matter. And because you define it globally, it doesn't matter if you have even 5 different instances of Log4j running. All of them just get disabled because of the environment variable. So I suggest looking at our blog post for that, and we suggest setting this environment variable globally, even if you plan to upgrade to 2.15 or 2.16, just because of the possibility of human error in upgrading. So this is the best mitigation that we believe. There's also other mitigations that are available. For example, you can pass a specific Java option to the JVM while you invocate your Java application, format message no lookups, but as not as an environment variable, but as a JVM option. We still think the environment variable is better because you can have it very easily globally on the entire machine. Also, there's older Log4j versions which don't support these properties. In this case, you'll have to, we also supply a command. It was also supplied in the original NVD advisory, that you can search for all of the vulnerable Log4j core packages, like the jar packages, and just remove the functionality directly from the jar file. It's a simple command. That should really be a last resort because this is very prone to human error. Like again, there could be jars inside jars. There could be a specific path that isn't exactly what you expect it to be. So this is really like the last resort. And if you would be in this situation, I would really suggest upgrading Log4j and not doing this mitigation, but it is possible. There's also another mitigation which comes from Java itself. So for specific versions of Java, like actually they're not even that new anymore. Like it's even for 2-year-old versions. Java actually were proactive and denied any deserialization of remote classes through JNDI. It's just a mitigation that is always configured in newer versions of Java. We have the exact versions on our blog post, of course. So some have been also saying, oh yeah, if you're using a newer Java version, then you're actually not exploitable. So this is true to an extent. There might be some factors on your specific machine that make the issue even exploitable if you're using a newer Java version. And also, even though the remote class loading is unavailable in the newer Java versions, there are some other vectors that can be exploited as well, such as information disclosure, even in these newer versions. So actually in our blog, we have a dedicated appendix for that. It's a bit technical, but we feel it's very exhaustive. So if you're stuck in this situation that you can't do any mitigations, you can't upgrade, but at least you have a newer Java version, or at least you can upgrade the Java version, but not the Log4j version, we highly recommend checking that part out. It's Appendix B in our blog, and it has an exhaustive list of what we know, at least, of how to exploit this issue even in newer Java version. So we recommend checking this out. So last but not least, we want to talk about our own detection. Let me share that. So last but not least, we also wanted to clarify to our own customers of JFrog Xray that, of course, this issue is detectable through Xray from day one with the specific research data that's coming from our security research team. So, as always, you're getting private research data with all the specific mitigations. For example, from day one, we didn't include the Log4j API package because we tested it and saw that it's actually not exploitable. So you wouldn't get this false positive through Xray. And just letting know to our customers that, of course, you can detect this issue both through our UI, CI/CD, the command line interface like JFrog CLI, and also our JFrog IDE plugin, which is available for Visual Studio Code and other IDEs as well. Like this would be detected. This was detected from day one on all of these. So for all of our customers, you can feel safe to search your code, your third-party code, and detect this issue and upgrade as needed.
No, this is great. I think that was some amazing conversation. I think that was some great information that you provided, Shachar, so I really appreciate it. I hope everybody on the call appreciates it. As a reminder, we will be sending out the recording of this webinar, so not to worry. We'll also be sending you some additional resources. Shachar, he did mention the blog. We will provide that in the email that we provide you post-event. If there's a question that we couldn't get to, please email webinars@jfrog.com. That's webinars@jfrog.com. And we will get those questions answered to you within 48 to 72 hours. But we are open for questions and answers. So please put anything you need, anything you're curious about in the Q&A chat box. But anything else, I think that was some great information. Shachar, thank you for your time and effort today. We appreciate it, and everybody else coming on for the call. We truly appreciate it, and thank you again. Shachar, if you want to just give a quick goodbye, and then we'll send everyone on their way.
Sure. So thanks again. I hope it was helpful for everybody, and we'll really love to take Q&A on this since we've been researching it since it came out, and we'd love to help anyone with upgrading, mitigations, detections, etc. Thank you.
Yes, thank you, everyone. Bye-bye.